Hi, I'm Assistant Professor Aditi Mathur, International Schools of Business Management, Suresh Kanviya University, Jaipur. And today, the topic which we'll be discussing in this video lecture is very short but very important. That is IsoQuants. So what do we mean by the IsoQuant? IsoQuant is a locus of points representing different combinations of labor and capital. An isoquant curve in which iso is a Greek origin and means equal or same, and quant means quantity. So that means it is a curve which shows different ratios in which we have equal quantity. An isoquant may be defined as a curve showing all the various combinations of two factors that can be produced and at a given level of output. So that means if let us just assume that we are shirt manufacturing company, so at the output level of let's say 100 units, IsoQuant is a curve which shows the different ratios in which any two factors of production can be used in such a fashion that we always receive 100 units of output. So let us just take an example that we have our inputs or the factor of production as land and labor. So the different ratios or the different combinations which help us out to always achieve the same level of output. And this combinations and the ratios when plotted on a graph and a curve is drawn is known as your IsoQuant curve. The IsoQuant shows the whole range of alternative ways of producing the same level of output. The modern economists are using isoquant or isoproduct curves for determining the optimum factors of combination to produce certain units of a commodity at the least cost. So it helps us to determine the level of the inputs which will help us out to produce the certain number of outputs at the least cost possible. How the cost element is associated with this curve, we will learn at the end of this session. So this is how our IsoQuant schedules look like. We have various combinations of two factors, that is factor X and Y. They are the inputs and the different combinations at which we can produce the same level of output, that is 100 meter. So whether you have a combination of X and Y in the ratio of 1:14 or 2:10 or 3:7, 4:5 or 5:4, the output is your 100 meters at all the possible combination levels. And this is what is known as IsoQuant. So when this IsoQuant data is presented or represented in a tabular format, it is known as IsoQuant Schedule. And when the same thing is represented graphically on a graph and a curve is drawn, so that curve becomes your IsoQuant curve. In the table which we have seen above, it shows that a producer employs two factors of production, X and Y, for producing an output of 100 meters of cloth. There are 5 combinations which produces the same level of output, that is 100 meter of cloth. The factor combinations A uses 1 unit of factor X and 14 units of factor Y to produce 100 meters of cloth. The combination B uses 2:10. For combination C, C, D, and E, we use 3 units of X and 7 units of Y, 4 units of X and 5 units of Y, And for the E, we use 5 unit of X and 4 unit of Y to produce the same level of output, that is 100 units, that is 100 meters. The producer here is indifferent as to which combination of input to be used for producing the same amount of output. Because at the level of A, B, C, D, and E, at all these levels, the only difference is that they are in different ratio. That means 1 is to 14 or 4 is to 5. But the output is coming to be 100 only. So as a producer, I can just pick any of the combination and get my 100 units. That means the 100 units meters of the cloth. But the cost factor is to be taken into the consideration. So that cost part, let it be right now. We will understand it in the upcoming slides. But for right now, the producer is in indifferent position. He is in that state of dilemma that which to choose and which not to choose, because the output is same. An IsoQuant, therefore, is a graphical representation of an ISO product schedule. It may here be noted that all the factor combinations of X and Y on an ISO product curve are technically efficient combinations. The producer is indifferent as to which combination he uses for producing the same level of output. It is in this way that an ISO product curve is also called as production indifference curve. Because over here, the producer is in indifferent position. All the combinations are giving him the same output. So that is why it is also known as production indifferent curve. So this is how our production indifference curve or IsoQuant curves look like. On x-axis, we have one of the factors of production, and whereas on y-axis also we depict the another factor. So in our previous example, we took factor x and y, and same are represented in x-axis and y-axis respectively. So now let us just discuss the properties of IsoQuant one by one. So if we talk about our first property of IsoQuant, it is an IsoQuant slopes downward from left to right. So you can see it over here. An IsoQuant curve is downward sloping from left to right. This implies that the IsoQuant is a negatively sloped curve in the economic region. It is because when the quantifies of factor K, that is capital, is increased, the quantity of L, that is labor, may be reduced, and so as to keep the same level of output. Over here, we can see and understand that to maintain the balance in the number of outputs, we sacrifice one factor so that we can increase the another factor. And this is how it becomes in such a ratio that we always get the same level of output. So this is one of the another picture, a clear picture for the IsoQuant curve. It is downward sloping from left to right. And it is because that, let us just take this point as our base, that we have used 4 labors and 5 units of capital. And I'm getting 100 units as my final product. So if I increase my labor to 16, right, I am actually reducing my capital from 5 to 2, and this is how I have came up to this point. So can you see that why the curve is downward sloping? Because to get one extra unit of our one factor, we are sacrificing or we are reducing the input of another factor. And because of this, our curve is downward sloping from left to right. The second characteristic is that an isoquant that lies above and at the right of the another represents a higher output level. It means higher isoquant represent higher level of output. It shows that the greater output can be secured by increasing the quantity, combinations of X and Y. The producers increases the output from 100 units to 200 units by increasing the quantity combinations of both X and Y. So you can see over here that at IsoQuant level 1, we are having 100 units of output, but at 2, we are having 200 because we have increased both the capital and the labor. But previously, we were increasing one and reducing the another. If you can see over here, see, one was increasing, the another was decreasing, and that is why we were on the same level of output. But the moment we have increased both the factors, we have shifted from one point to another point, that is from 100 units to 200 units of output to the upper level. And that is why one of the characteristics says higher the isoquant depicts the higher unit of output. And that is why it is above each other. So this is how our point number 2, the characteristics gets justified, that the isoquant that lies above and to the right of the another represents a higher output level. So we can see over here, it is above and towards the right, and it depicts higher value. Now let us just discuss the third characteristics, that is isoquants cannot cut each other. Two isoquants cannot intersect each other. If two isoquants are drawn to intersect each other, then it is negotiation of the property that the higher isoquant represents higher level of output to the lower isoquant. So let us just take a situation where I am saying that this is my isoquant 1 and this is my isoquant 2. And as they both are intersecting, that means it has a same point, and that means that the output at isoquant 1 is equal to the output at isoquant 2, which is practically not possible. Because we have said that if it would have been a same, they would have been on the same graph or the same line. So that is why we say that never ever the two isoquants intersect each other. You see? So if this point E exists, that says that this is that ratio of B and A where we can produce 200 units of output and 100 units of output both. So that means if I have B number of labors and A number of capital, I can produce both 200 units also and 100 units also, which is not practically possible. I can only produce one quantity of output if I have B is to A. I cannot produce two quantities of output when I have the same ratio. So that is why we say that the two isoquants never intersects each other. If in examination, whenever you are drawing the isoquants and you find out that they both are intersecting each other, so please take a time, recheck and calculate your work, because the two isoquants should never intersect each other. Fourth characteristic is that the isoquants are convex to the origin. This property implies that the marginal significance of one factor in the term of the another factor diminishes along as isoproduct curve. In other words, the isoquant are the convex to the origin due to the diminishing marginal rate of substitution. So with the help of this point, we are telling that our isoquant curves are convex to the origin. They are downward sloping from left to right, and it is because of our diminishing marginal rate of substitution. Now let us just understand a very important aspect of our isoquants, that is IsoCost lines, which is also known as IsoCost curves. As the term itself says, IsoCost, that means now we are looking into the matter of money, that means cost. An IsoQuant line is also called outlay line or price line or factor cost line. An IsoQuant line shows all the combinations of labor and capital that are available at a given total cost of the producer. Just as there are indefinite number of isoquants, there are infinite number of IsoQuant lines. The one for every possible level of given total cost. The greater the total cost, the further from the origin of the IsoQuant line. So now let us just see how our IsoQuant looks like. So this is how we draw our IsoQuant curves. This shows the different ratios of combination of the cost related to the labor or the capital in this question, at which we are producing the same level of output, or we are coming up to the same cost, total cost. That means if I am at this point, all the possible combinations of the cost, individual cost incurred over here for my capital and labor, they will be all equal to 100. Higher the isoquant, higher the total cost. The nearest the isoquant to the origin, it is the lowest amount of the isoquant. Let us just take a small example and understand the concept. For example, a firm which wishes to spend 100 rupees on a combination of two-factor labor and capital for producing a given level of output. We suppose further that the price of the 1 unit of labor is 5 per day. This means that the firm can hire 20 units of labor. On the other hand, if the price of the capital is 10 rupees per unit, the firm will purchase 10 units of capital. The point A shows 10 units of capital used, whereas point T shows 20 units of labor are hired at the given price. If we join point A and T, that we get the line AT, and this AT line is called IsoQuant line or outlay line. The IsoQuant line is obtained with the outlay of rupees 100. Now let us just assume that there is no change in market prices of the two factors of labor and capital, but the firm increases the total outlay of 150 units. So before we were having a total expense or the total outlay of 100, but now we are going to have 150. The new price line BK shows that the outlay of 150. The producers can produce 50 units of capital or 30 units of labor. The new price line BK shifts upward to the right. In case the firm produces the outlay to be rupees 50 only, the IsoQuant line CD shifts downwards to the left of the original cost line and remains parallel to the origin. So this is what we are actually discussing, the AT, the BK. So if we have increased our overall cost to 150, this will be upward, and the ratio over here will show that our total ratio of the cost of capital and labor will together add up and come up to 150. But before we were having 100, that's why this is our ISO cost line for the 100 ISO. IsoQuant line plays a similar role in the firm's financial decision making as the budget line does in the consumer behavior decision. The only difference between the two is that the consumer has a single budget line which is determined by the income of the consumer, whereas the firm faces many ISO cost lines depending on the different level of expenditure the company might make. So if we plot our IsoQuant line and we have IsoQost, ISO curves, our IsoQuant curves, that is your IsoQuant curve 1, IsoQuant curve 2, IsoQuant curve 3, and this is our IsoCost curve. So we are going to select this level because it is under our budget and it is giving us the output which we want under our budget. So this is how the firms decide that which quantity is to be produced under a budget. And that is why the IsoQuant lines plays a very vital role. So now let's just have a very quick recap of what we have studied today. We have studied an important topic, that is IsoQuant. IsoQuant word means a locus of points representing combinations of labor and cost. The word iso is a Greek word which means equal or same, and quant means quantity. So we can therefore say that the IsoQuant shows the whole ranges of variable alternative ways of producing same level of output. This is how our IsoQuant schedules look like. So we have different combinations of our two input factors and which gives us same level or a steady level of output. And over here we say that the producer, the factory, is in indifferent position that which output level, which combination level or which combination of the factors to be taken into consideration. Because at all these factors or the combination, the company is producing the same level of output. We understood few characteristics. The first characteristic was that the IsoQuant slopes downward from left to right. Then we saw that the IsoQuant lies above and to the right represents the higher output level, 100 and 200. IsoQuants never cut each other. That means they cannot cut, otherwise it will be a great misconception towards the IsoQuant theory itself. Then we even discussed that the IsoQuants are convex to the origin because of the diminishing marginal rate of substitution. We discussed about the IsoQost lines or IsoQost curves. This is how we draw the IsoQost line or the curves. In this, we share or we have the different ratios in which we can use or deploy our labor and cost at a given total cost. So if we have total rupees 100, this is how I can deploy and employ my different factors of productions like labor and capital, so that my total cost comes to 100. If it is 150, my line will shift from AT to BK. And if it is 50, it will shift to CD. So now let us just have a quick recap of the IsoQuants with the help of the MCQ questions which I have prepared. These 10 set of questions will help you out to understand the IsoQuant theory more clearly. So all the best everyone, and do hope that you score 10 on 10 in this mini quiz. So the first two questions are on your screen. Question number 3 and question number 4. Question number 5 and question number 6. Question number 7 and question number 8. And the last two MCQ question of this video lecture, that is question number 9 and question number 10. Read the question 10 very carefully. It is a bit confusing, but very easy to identify the correct option. So now let's just discuss all the correct options or the answers of this test, MCQ test. So the correct answer for question number 1 is option A. For question number 2, the correct answer is option B. For question number 3 and question number 4, the correct answer is option A. For question number 5, the correct answer is option C. For question number 6, the correct answer is option E. Question 7, the correct option is option C. Question number 8 and question number 9, the correct answer is option B. And for question number 10, the correct answer is option C. I do hope that you all have scored 10 on 10 in this MCQ test. So before I wind up, let us just quickly have a look on all the slides which we have discussed today. So we have discussed what do you mean by IsoQuant. Then we learned about the schedule. Then we saw the few characteristics that means that IsoQuant slopes downwards from left to right, IsoQuants that lies above and the right of the another represents a higher output level. IsoQuants cannot cut each other. IsoQuants are convex to the origin. Then we also discussed the IsoQuant lines or the IsoCost curves. And then we solved the 10 MCQ questions. So thank you everyone for watching this video lecture, and I do hope that now you have a clear understanding of the topic IsoQuants. Thank you and happy learning.